In this question, hydrochloric acid, HCl, dissociates in aqueous solution, that means in water, to form H plus and Cl minus. The H plus then reacts with water to form H3O plus. We're told some HCl is added to water, and after some time, the solution reaches equilibrium. The amount of each species present initially and at equilibrium is represented in the images provided. Each molecule represents 1 mole of the substance. So we can see we have our initial and equilibrium representations of what's going on in our solution. We're asked to complete the table to determine how many moles of each substance are in the solution before and after the HCl dissociates. So the 3 things we're looking at are HCl, H3O plus, and Cl minus. So let's have a look in our initial diagram. I can see one HCl there, another one there, and another one there. So we've got 3 HCls, or 3 moles of HCl. I don't see any Cl minus, and I don't see any H3O plus. So I'm going to put a 0 in both of those. Now at equilibrium, for HCl, I don't see any HCl. So I'm going to put a 0 for that. What about H3O plus? I see 1 here, I see 1 here, and I see 1 here. So that's 3 H3O plus. And for Cl minus, I see 1 here, 1 here, and 1 here. So that's 3 Cl minus. So we're then asked, does HCl fully or partially dissociate when dissolved in water? So dissociate means split into its ions. And we can see here we started with 3 moles of HCl and we ended up with 0 moles of HCl. So all the HCl added split up into its ions to form H3O plus and Cl minus. So that means the HCl fully dissociated. We're next asked, is HCl a strong or weak acid or base? So strong, that means the acid or base fully dissociates. Weak, that means the acid or base only partially dissociates. In other words, you would have some of the original compound like HCl left at equilibrium. So based on that, since HCl fully dissociates, it must be strong. And is it an acid or a base? Well, since it's giving up H plus ions, it's donating H plus, that means it must be an acid. So we have a strong acid here. Finally, we're asked to write an equation to represent HCl dissolving in water. So the thing we have to select here is the arrow. Is it a equilibrium arrow with the forwards and backwards arrow? That's showing the reaction doesn't just go forwards, it goes in the forwards and the backwards direction and reaches some equilibrium in between. This arrow shows the reaction goes forwards only, meaning that all the HCl is going to dissociate into H plus and Cl minus. Since we have a strong acid that's fully dissociating, we're going to choose this arrow here. Let's do one more question of this type. In this question, we have iron 3 hydroxide, FeOH3, dissociating in aqueous solution to form Fe3 plus and OH minus ions. We're told some FeOH3 is added to water and left for some time until the solution reaches equilibrium. Again, we're shown the initial and equilibrium representations of what's going on in that solution. So let's figure out how much of each substance we have initially and at equilibrium. So initially, first we're looking at FeOH3. We've got 1 here, we've got another here, and we've got another here. So we've got 3 moles of FeOH3. What about Fe3+? I don't see any here initially. And OH-, again, I don't see any here initially. So those are both going to be 0. Then at equilibrium, I'm looking for FeOH3. Here's one, and here's another. So I've got 2 FeOH3 at equilibrium. What about Fe3+? I've got 1 Fe3+ here. That's all for that, so I'll pop that there. And then for OH-, I've got 1, 2, 3 OH- at equilibrium. So we can see that one of our FeOH3 has split up to give Fe3+ and 3 OH-. So the next question asks, does FeOH3 fully or partially dissociate when dissolved in water? Well, only one of the 3 moles shown in the diagram actually split up into its ions. So we're only partially dissociated. So is it a strong or weak acid or base? We know it's going to be weak because it only partially dissociates, and we know it's a base because it's releasing OH- ions in solution. So we have a weak base here. Lastly, to choose our arrow here in our equation, it's going to be this arrow. This is the equilibrium arrow, showing we have both forwards and backwards reaction occurring. And therefore, we're going to have some reactants and some products at equilibrium. So to summarize here, the definition for a strong or weak acid or base is that a strong acid or base fully dissociates in water, and a weak acid or base only partially dissociates in water. So once you've counted up how much of each species we have initially and at equilibrium, if the initial compound fully dissociates, it's strong. If the initial compound only partially dissociates, it's weak. Finally, to choose your arrow for strong acids or bases, we're going to use that solid arrow, showing all our reactants get converted into products. If it's a weak acid or base, we're going to use that equilibrium arrow pointing both directions, showing only some of our reactants get converted into products.